The normalization process is based on identifying something called functional dependencies, and it's a big scary word with a big scary definition. So this is likely the first concept where students will tend to struggle. So we'll try to walk through this with a few examples. We'll start with the formal mathematical definition, where we have A and B, or two sets, and basically A uniquely identifies the values for the set of attributes B. Then we say that B is functionally dependent on A, and we sometimes write this with a little arrow that A determines B is sometimes how it's said. You could also say each value of A must be associated with exactly one particular value of B. And then A and B are both sets of attributes. So for example, if you had a composite key, that could make one of your sets A or B. Let's take a look at this in terms of some more concrete examples. So here we are back to our trusty instructor table with a list of instructor IDs and names. The first thing we'll check out is instructor ID, does that determine first name? Is it a functional dependency? The answer in this case is yes, because for any given value of instructor ID, we get a unique first name back. And then for last name, does that determine the instructor ID? In this case, no, it is not, because last name doesn't necessarily uniquely identify the instructor ID. So if we had more than one last name in our database, that we could not determine the instructor ID given just the last name. On the first one, does instructor ID determine first name? The way you can think of it, even though we have duplicates first names with Andy, is that given an instructor ID, could we definitively determine what the first name is? In this case, yes. So if we had instructor ID 76, we could definitively determine that the first name was Andy. In the second case, if we were given a last name, in this case Furman, could we definitively determine what the instructor ID is? The answer is no, because we might have another Furman in the database, might be associated with another instructor ID. And so the first step in normalization is to identify these functional dependencies, and we'll show you a few examples of notations that we use to do that. Now there are a couple of types of functional dependencies. The first one is what I'll call a trivial functional dependency, and this is where the right-hand side of the functional dependency is a subset of the left-hand side. And so in this case, instructor ID determines instructor ID. That's not very interesting. And even if on the left-hand side you had instructor ID and first name determining instructor ID, again, this is true, and it is a functional dependency, but that does not tell us any real interesting information. So the real interesting functional dependencies, the non-trivial functional dependencies, represent genuine integrity constraints. So instructor ID determines first name, instructor ID determines last name, and so on. And of course, some of these are easy to identify when looking at the database. A unique constraint is a good place to look for a functional dependency. Obviously, primary keys and candidate keys that result from converting your ERD, and then functional dependencies in relationships, as you see here. Difficult functional dependencies are where the left-hand side is not a primary key or a candidate key in a converted table, or the left-hand side is part of a combined primary or candidate key, like a composite key. And so the notation that we use, and this is shared by your textbook, for illustrating functional dependencies, is to draw arrows along the columns of the particular relation. And in this case, we have our course instructor table, and the course number and section number form a composite primary key. The course number determines the title of the course. The course number combined with the section number determines the instructor of the course. So IDSC 3103, section 1 has a particular instructor, and section 2 may have a different instructor. And then finally, the instructor ID determines the first name and the last name of the instructor. And so this is an example of one of those interesting dependencies where the left-hand side is not a key, a primary key or candidate key for the table. And so these dependencies are the most interesting ones to find when we're trying to normalize for data. Some dependencies are transitive dependencies. So in other words, if A determines B and B determines C, then that also means that C is determined by A as well. And so in our previous example, we have the first functional dependency, course number and section number determine instructor, and instructor determines first name and last name. And so therefore, course number and section number also determine the first name and last name of the instructor. And this is called a transitive dependency, named after the transitive property of arithmetic that you probably learned in elementary school.